All right, guys, so before we get started, questions over any of the homework assignments. So any of the problems that you have questions on, didn't understand, want to see done.
Is the package that you gave me yesterday that like extra file?
So 741 is what we did this week. So, because I know you weren't here yesterday or the day before. Were you here Monday?
Yeah.
Okay, so 741 is what we did. I'll probably need to get you a packet. I think I gave you that one.
I also wasn't here Tuesday, Wednesday, Thursday last week.
Okay, we'll have to get you those packets and see what that is. Also, there are some over here. Welcome. All right. All right, guys, so what we're looking at today is simplifying complex fractions. A complex fraction is a fraction in a fraction. Now, there's two main ways to simplify it. Fraction in a fraction, a complex fraction. So, all right, guys. So, there's two ways to do this. There's two ways to simplify it. The first way is that we simplify the fractions on top and bottom so that there's a single one. So that we only have one fraction on top of the fraction and one on bottom. And the second way is using least common denominators to simplify this here. I'm going to show you guys method one. I would advise watching it, not so much just kind of watching it. And then we'll do this again with the second method. Now, the first method is to get the fractions on top and bottom to be a single fraction. Now, the top of this is fine, because it is one fraction, 5 over x plus 4. But the denominator, we have 2. So we need to add those together to give us a single fraction. But for us to be able to add or subtract, we need the denominators of the bottom of this fraction to be the same. Now, the least common denominator for this here with x plus 4 and x is actually x plus 4 times x. So the one on the left, we need to multiply it by x over x. The one on the right, we're going to have to multiply it by x plus 4 over x plus 4. And when we do this, take 2. There we go. When we do this, the numerator is still, well, 5 over x plus 4. The first denominator here, x times 1, is just going to be x. On bottom, we're going to have x times x plus 4 plus. Our other denominator is going to be x times x plus 4. Now, the numerator, we're going to have to distribute the 2. Our 2 times x is 2x. Our 2 times 4 gives us plus 8. And we've done this so that the denominators are the same. And since the denominators are the same, we can add the numerators. And the denominator of this denominator is going to be our x times x plus 4. We can add the numerators. Our x plus 2x plus 8. Normally we would put parentheses around it, but addition, the signs aren't going to change. We don't have to distribute anything through it. It's just we don't necessarily need them. Next thing we can do is combine like terms. 5x over x plus 4. Well, our x plus 2x is going to be 3x plus 8 over x times x plus 4. And this was the main goal, to get one fraction on top and bottom. Now, fractions is just another way to say that we're taking the top of the fraction, which is our 5x over x plus 4, and dividing it by the bottom. That's all a fraction is, yes. because my brain decided to add an x, which is 5. Thank you. Yeah, again, if you see something like that, ask. Somewhere in the space of my head, I added a number. Yep, it should just be 5. Now, top of the fraction divided by the bottom. That's all this is. That's all fractions are. So, guys, up here. With division, we can keep the first the same, change it from division to multiplication, and flip the second. Tells us that we have 5 over x plus 4 times x plus 4 over 3x plus 8. And when we multiply this, on top we'll get 5x plus x plus 4 over x plus 4 times 3x plus 8. And if we notice here, there is something in common on top and bottom, which is x plus 4 and x plus 4 cancels, telling us that this is 5x over 3x plus 8. There's nothing in common on top and bottom. We can't reduce the 3x plus 8 any farther than this here. So this is what we get. All right. Let's look at the second method, least common denominator. We want to find the least common denominator of the denominators of the fraction. So there's 3 denominators in this fraction total. On top, we have an x plus 4 as the only denominator. On bottom, one of the denominators is x plus 4, and the other is x. Now looking at these 3 denominators, well, we know we'll need x plus 4 at least once, as it is going to be a part of the least common denominator. Does it show up in any of the denominators more than once? Well, no, it does show up in 2 spots, but in each of those spots, it only shows up once. So we only need it once. And the only other factor that shows up in any of the denominators is x, and the one time it shows up, it only shows up once. So the least common denominator of this entire fraction is x times x plus 4. Questions on this so far? No. We need to find it first. And what we're going to do with it is we're going to multiply this fraction on top and bottom by x times x plus 4. So this x times x plus 4 is going to multiply by the numerators in the numerators of this fraction and the numerators in the denominator of this fraction. So on top, fraction, this x times x plus 4 is going to multiply with our 5. Well, 5 times x is going to be 5x times our x plus 4 over x plus 4. On the bottom of the fraction, we're going to do the same thing. Our x times x plus 4 is going to multiply with the 1, which is going to give us, well, x times x plus 4 over x plus 4 plus. We're going to multiply the x times x plus 4 with 2, giving us 2x times x plus 4 over x. Questions on this so far? I understand what we did here, yes? With the multiplication? Yes? No? Question? Let's ask the questions now, because if we ask them now and then ask them on the review, we all understand them better on the review. Okay, do you understand how we got the x times x plus 4? Yes. So we're going to multiply on top and bottom. Okay? So x times x plus 4 on the top We have to multiply with the 5 on top, giving us 5 times x plus 4. Yes? Do it with the 1 on bottom, giving us x times x plus 4 over x plus 4. And with the 2, giving us 2x times x plus 4 over x. We get that there. Okay, now there's a reason we're doing this, and the reason that this works nicely. If we look at the top fraction, well, the x plus 4 and x plus 4 will cancel. So what's the only thing left on top? 5x. There is no fraction. That's the key. Not so much that there's a single term, but all the fractions in the top of this fraction are now gone. Let's see about the bottom. But the first one here, our x plus 4 and x plus 4 will cancel, leaving us with x. And lastly, the x and x here cancel, leaving us with plus 2 times That's why we multiplied by the least common denominators to get rid of all those fractions in the fraction. On bottom, we do need to simplify. We need to multiply by 2. Our 2 times x is 2x. Our 2 times 4 is 8. X plus 2x is? Done. There's a reason I told y'all to watch the first method. I think y'all like this method better. It simplifies things nicer. We don't have to worry about fractions and fractions. It works everything out a lot nicer, a lot simpler, and a lot easier. Questions on this here? Because this all revolves around being able to find this least common denominator. Once we find it, we multiply through top and bottom to get those fractions to reduce and simplify out. Look at another one. Least common denominator. If we look at the 3 denominators, one factor that does show up at least once is what? X minus 2. It does show up in 2 different places, but in each denominator, how many times does it show up? Once, so we only need it once. Any other denominators that we haven't taken care of or accounted for? X. And it only shows up once in one spot. So the least common denominator, what we're going to multiply everything by, is x times x minus 2. X times x minus 2. And we multiply this, we're always multiplying this through the top of each of these fractions. So we're going to multiply the x times x minus 2 by our 6, giving us 6x times x minus 2. We're going to do the same thing on the bottom. We multiply this x times x minus 2 with our 1, is giving x times x minus 2 over x minus 2 plus our x times x minus 2 when multiplied by our 3 gives us 3x times x minus 2 all over x. On top, the x minus 2 and x minus 2 will cancel. On bottom, again, the x minus 2 and x minus 2 will cancel. And here the x and x, leaving us with 6x over x plus 3 times x minus 2. Now, before we can say we're done, we need to make sure that we have this as simplified as far as possible. The numerator is just the term 6x. There's nothing we can do with it. But on bottom, we do have this 3 times x minus 2 that we do need to multiply through. and we multiply that through, we'll end up with x plus 3x minus 6. X and 3x are like terms. Well, x plus 3x is 4x minus 6. Is there a greatest common factor between 4x and 6? 2. We'll have to factor it out, giving us 2 times 2x minus 3. Six x and 2, that 2 out front will reduce. The 6 will reduce to 3, and the 2 is going to reduce to 1. It's not always going to reduce, but if it can reduce, we're going to need to, because it's not considered simplified or in simplest form unless there is no greatest common factor between the top and bottom other than 1 or negative 1. That's it. Questions on this here? We ready for the next one? X minus x over 6 minus x over 3 all over x over 5 minus 7/10. Least common denominator. Here we have a few numbers. We have 6, 3, 5, and 10. So we're looking for the least common denominator. We're looking for the first term. We can turn 6, 3, 5, and 10 in the first number, going up from there that we can make be the same. One thing I would suggest doing is, since we look at this here, what's the first number I can turn 6 and 3 into? 6, yes. Because 2 times 3 is 6, 6 times 1 is 6. So we can turn both 2 and 3 into 6, yes? Wait a minute. What's the first number I can make 5 and 10 be? 10. So at first it looks like we're looking at a least common denominator for 4 numbers, but really we can just look at a least common denominator for 2. So now we're trying to figure out what is the first number 6 and 10 can both be. 30. So our least common denominator for this problem is 30. It might be very tempting to want to say 60, but that's going to be a common denominator, not the least. So what we're going to do is come over here and multiply the top of this fraction by 30 and the bottom of the fraction by 30. And if we do this multiplication here, again, we're multiplying with the tops of the fraction. Our 30 times x is going to be 30x over 6. Minus, well, 30 times x is going to be 30x. But this time it's over 3. We'll do the same thing with the bottom of the fraction. Our 30 times x is going to be 30x over 5. Minus 30 times 7 is 210. All right. Let's start with the top. 30x divided by 6. 30 divided by 6 is 5, and we have x, 5x. Minus 30x divided by 3 is going to be 10x. 30x divided by 5 is 6x. Would not be 11. 21. Now we can simplify the numerator, because 5x minus 10x is what? Focus in, guys. Negative 5x. 6x minus 21, are those like terms? Is there a greatest common factor between 6x and 21? 3. We can go on and factor it out. If we factor 3 out of 6x, we have 2x. And if we factor the 3 out of 21, we get 7. Now, if there's going to be something that's going to simplify, it's going to be between our 5 and 3. Will 5 over 3 reduce? That's it. Let's look at this one here. Least common denominator for this is what? X. X is the only variable or expression in the bottom of the fraction. Shows up twice, but it only shows up in each one of those once. So we can multiply the top and bottom by x. Now for us here, our x times 2 over x is going to be 2x over x minus. Even though the 4 doesn't have a denominator, we're going to multiply the x with the 4, giving us 4x. We'll do the same thing with the bottom of the fraction. Our x times 2 over x gives us 2x over x plus our x times 3 is 3x. And as much as we want to cross out the 2x over x and 2x over x, because of the minus and the plus, they're stuck together. We can't just cross them out. But here the x over x will reduce, and here the x over x will reduce, leaving us with 2 minus 4x over 2 plus 3x. Yes. On bottom, 2 and 3x is their greatest common factor. No, and since the degree is 1, that's really as simplified as it gets. However, we can write it in standard form, 3x plus 2. 2 and negative 4x is their greatest common factor. 2. And we can factor the 2 out of negative 4x, giving us negative 2x. And the 2 factored out of 2, we get plus 1. I switched them, so if you still have it as 1 minus 2x, that's fine. That is still the same thing. I just like putting the variable first. Now, we can leave the negative in there with that 2x, because we could have factored the negative out, giving us 2x minus 1. But the only real reason we would need to do that is if the denominator was 2x minus 1. Because if both terms are opposite, factoring that negative out would make a difference. But here, no. This is the final answer. Questions on this here? We'll look at one more of those. I'll let y'all pick which one we want to see done. This one? Okay. Now, if we look at all 4 denominators, we do have a minus 2 and a. Now, each of those, a and the a minus 2, only show up once in each of their respective denominators. So, for the least common denominator, we only need each one of them once. And when we multiply this here, the a times a minus 2 times our 1 gives us a times a minus 2 over a minus. We're going to multiply this with our 3, giving us 3a times a minus 2 over a minus 2. We'll do the same thing with the denominator. And our first rational expression is going to end up being 2a times a minus 2 over a plus, and we do this with 5, we get 5a times a minus 2 over a minus 2. Let's see what's in common. So here the a and a cancel. Here the a minus 2 and a minus 2 cancel. A and a minus 2 and a minus 2. And what that leaves us is with a minus 2 minus 3a over 2 times a minus 2 plus 5a. On top, we can drop the parentheses, so we get a minus 2 minus our 3a. On bottom, all right, guys, when you distribute the 2, so 2 times a is 2a, 2 times negative 2 is negative 4, plus our 5a. Again, at this point here, we combine like terms. Our a minus 3a is going to be negative 2a minus 2. On the bottom, 2a plus 5a is going to give us 7a minus 4. Now, the 7a minus 4 won't simplify. They won't combine. They're not like terms. There is no greatest common factor. There's nothing we can do with it. The 2a minus, the negative 2a minus 2 does have a greatest common factor of negative 2. We could say 2 or negative 2. I pulled the negative 2 out because it gets our variable to be positive. But that's it. Questions on any of this here? Because even things crazy as this end up working out kind of nicely. So as much as it, because it does look like it would cancel out, but if, and it would if that had been plus. Because if it had been plus, we do have the same term on top and bottom, it divides out. Here, the first thing we can do, and you guys, you don't have to, we'd multiply the top and bottom by x plus 1 and x minus 1. And what that would give us on top here is x minus 1 times x plus 1 times x minus 1 over x plus 1 minus x plus 1 times x plus 1 times x minus 1 over x minus 1. On bottom, we'd have x minus 1 times x plus 1 times x minus 1 over x plus 1 plus x plus 1 times x plus 1 times x minus 1 over x minus 1. Now what that leaves us with is x minus 1 times x minus 1 minus x plus 1 times x plus 1. So we need to multiply these out. I'm going to be nice because if we do multiply these out, I'm going to skip a step here and actually do x minus 1 times x minus 1. We get x squared minus 2x plus 1. X plus 1 times x plus 1 is going to be x squared plus 2x plus 1. Now on top, we're going to have to distribute that negative through. So it'll tell us that we have x squared minus 2x plus 1 minus x squared minus 2x minus 1. A lot of terms. Yes. Yes. Now if we look on top, x squared minus x squared is 0. Those are gone. Negative 2x minus 2x is going to be negative 4x. And 1 minus 1 is 0. So out of all the terms on top of this fraction, we get negative 4x. On bottom, x squared plus x squared is 2x squared. Negative 2x plus 2x is 0, and 1 plus 1 is 2. There's a greatest common factor of 2 between our 2x squared and 2. And the negative 4 over 2 is going to reduce to negative 2x over x squared plus 1. And it's kind of interesting that that entire thing reduces to just that. But nothing that crazy on the homework.